Welcome to The Explainer. Today, we're diving into the incredible story of how a small team managed to reverse engineer ESPN to build a massive sports prediction engine, and they did it all without paying a single dime for data. Okay, so let's just think about this for a second. If you wanted to build a model to predict sports, really predict them with any kind of accuracy, what's the absolute first thing you'd need? You'd need data, a ton of data. And right away, you'd hit a massive wall. See, professional, commercial-grade sports data feeds, they can easily cost you $500 a month, maybe even more. For a small team or just one person trying to build something cool, that cost is a total non-starter. So that price tag seems to be the cost of playing the game, right? But what if it wasn't? What if there was a different way in? A kind of back door that could give you access to everything you needed for free? Well, the team behind this project found exactly that. They stumbled upon a hidden treasure, an undocumented API that actually powers ESPN's own website and all their mobile apps. It was just sitting there, out in the open, waiting to be discovered. So what even is an API? The simplest way to think about it is like a private language. It's how a website's front end, the part you see, asks its server for information. Hey, send me the latest scores. All this team did was learn how to speak that language directly. And you won't believe the kind of data they found inside. We're talking about live scores, super detailed play-by-play info, team stats. They even found ESPN's own win probability estimates. It was all there, perfectly structured, ready to be used, and, best of all, completely free. So finding that API was a huge win, a total game changer. But, that was really just the beginning. The real engineering challenge was figuring out how to collect data from tens of thousands of games on a massive scale without getting your hand slapped and shut down. In the end, they built this incredible data pipeline that successfully captured, get this, over 25 million in-game snapshots from more than 60,000 games. And this wasn't just one sport. It covered 7 different sports, from the NBA to women's college basketball, going back for years. So how on earth did they do it so fast? Well, instead of using a slow scraper that fetches one game at a time, they built an asynchronous system. Think of it like this. The slow way is one person at a grocery store checkout. The fast way is having 20 cashiers open at once, all working in parallel. This let them scrape an entire season of games in a matter of minutes, not hours. So by cleverly getting around all those technical hurdles like rate limiting, and then meticulously cleaning up all the data to handle weird edge cases like overtime or postponed games, they built an absolutely incredible foundation. The raw material for their entire prediction engine was now ready to go. All right, so you've got this mountain of perfect data, 25 million rows of it just sitting there. Now what? How do you actually turn all that information into a system that can predict the future of a game while it's happening? They came up with this really elegant 4-step pipeline. So first, they calculated something called Elo ratings for over 900 teams. It's basically just a way of measuring a team's skill level. Second, they used that data to train their own custom win probability models. Third, and this is key, they detected edge. They'd find games where their model's prediction was way different from the betting markets. And finally, they automated the whole thing. Okay, now this is where things get really fascinating. Because building this whole system from scratch, it uncovered some truly unexpected insights. We're talking about lessons that pretty much go against all the conventional wisdom you hear in sports analytics. After sifting through years and years of data across thousands of games, a few really powerful lessons started to emerge. And I'm telling you, they're probably not what you'd think. So, lesson number 1. Their biggest performance boosts didn't come from some super complex, cutting-edge algorithm. Nope. They came from the boring, meticulous work of just cleaning the data, making sure overtime rules were handled correctly, filtering out postponed games, ensuring every single data point was perfect. Clean data, it turns out, beats a fancy model every single time. And then there's lesson number 2, which is just so counterintuitive. Initially, they were just going to ignore ESPN's own predictions. But then they realized ESPN's model was picking up on stuff theirs couldn't, like in-game momentum. So instead of tossing it, they did something brilliant. They fed it into their own model as a feature. They essentially taught their system to learn when ESPN was likely right and when it was likely wrong. And this might be the most crucial takeaway of all. Their biggest profits didn't come from the big leagues like the NBA or the NFL. The most consistent edge was actually found in less popular markets, like men's and especially women's college basketball. Why? Well, because fewer experts are watching, the market prices are just less efficient. And this quote from the team, it just sums everything up perfectly. Their unique advantage, their competitive moat, it wasn't some secret algorithm. It was the data itself. The hard, unglamorous work of building and maintaining a world-class data pipeline. That was their real edge. This whole project really makes you wonder, doesn't it? How many other undocumented APIs and hidden data sources are out there, quietly powering the digital tools we all use every single day, just waiting to be discovered?